Hello, everybody. This is Madhuri Perry. I'm a senior Spot specialist essay with Amazon Web Services. Today, I wanted to share with you how to use EC2 Spot with EMR and big data services in general. So, with that said, I wanted to take a look at the agenda of items that I'm going to cover today. First, we are going to look at why we want to choose EC2 Spot with EMR. In lieu of that, we are going to cover with a recap of what EMR architecture looks like. We are going to also refresh concepts on EC2 Spot, market, and the pricing, and some of the workload patterns that we have seen customers use on EMR with EC2 Spot, and what are some of the choices once you choose Spot to launch your instances and to manage your instances. We'll also cover the operational aspects of a Spot instance related to how the instance would be terminated and also some of the other bootstrap procedures that are available to you. So with that said, let's get started with our items here. So first off, we want to cover what EMR architecture would look like. So you are already familiar with how EMR brings together and simplifies multiple layers and components that are involved in its ecosystem. So this involves having infrastructure, which is a group of servers that would be provisioned and managed by EMR. It also provides the HDFS, which is available for data layer management. In addition, you also have your MapReduce or Taze or Spark frameworks that you would be using to perform your big data operations. All of this is being run on top of Hadoop framework. So when we are looking at the complete picture, there are a lot of applications that run on top of a Hadoop cluster, which involve things like Presto or Apache HBase or Hive or Pig. There are also Spark SQL, Spark Streaming, all these variations of applications that you could run based on your business need. When you are talking about processing huge amounts of data, big data, with a EMR-based cluster, you obviously need to manage your data in some sort of data source. In this particular case, what we are highlighting is Amazon S3. And in order to make optimized use of data that's available in Amazon S3, you do have EMR FS, which is a driver that's operating with your data that's on S3 as well. So with that said, I do want to see where does EC2 Spot help you with all of this framework and managed service that EMR provides. Two things I want to highlight before we move away from this slide is the first one is essentially compute and storage. These two have to be thought of as a decoupled architecture. So when you're that gives you an additional flexibility of choosing compute as an entity and to optimize it, and that's where Spot comes into picture, EC2 Spot comes into picture. The second aspect is essentially it is also going to give you the scale to process your big data jobs faster and be able to lower the cost as a side aspect of it. So with that said, essentially, I'm just trying to highlight here how EC2 Spot could help big data and EMR architectures to optimize both the cost aspect of the compute and also give you the elasticity. So some of the benefits of EMR you might be already familiar with include automation, which will essentially speak to how you could leverage the CLIs and the APIs and the cloud formation mode of provisioning and management for the clusters that you're spinning up. In addition, we also spoke about decoupling the compute and storage, which will enable you to amplify the benefit by leveraging EC2 Spot for compute aspect of your cluster. In addition, there are these other aspects related to integration where EMR allows you to integrate with other AWS services like CloudWatch, Kinesis, and so on. We also have the ability to roll out new releases faster with Apache BigTalk, which basically means if you are looking for a specific feature in Apache Hadoop that you want to use in EMR, you can spin a different version of the cluster, which is much later than what you're using, and able to leverage that particular feature of EMR as well. These two aspects which are highlighted in blue here are the benefits that are really front and center when you're using EC2 Spot. The benefits being elasticity and low cost. Because you are paying a much less price for the instances when using EC2 Spot, that definitely is tying into the low cost aspect. And in addition, when you are using lower cost, you are able to increase your scale, and that's why the elasticity component of the benefit is highlighted as well. Moving on to the next slide, we want to now tie in all these benefits, how they look from the aspect of cost and time. So when you're looking at running a job on your EMR cluster, how does it show up from point of cost and time? So at this in this slide on your left hand side, what you're seeing is there are two axes. Time is represented on x-axis and the number of nodes in your cluster is represented on y-axis. So what you're trying to showing here is essentially the amount of time that it takes to run a job to completion is more when the number of nodes are less. So when you're trying to add more nodes to your cluster, as highlighted by the elasticity and low cost aspect of EC2 Spot, you are able to complete the job much faster with a more number of nodes. So when you're looking at all these, definitely it makes sense from both a scale and a cost perspective to run a big data workloads with EC2 Spot. With that said, let's just recap what EC2 Spot is. So essentially, you're already familiar probably with the EC2 instances when they are launched on demand. It basically is taking and launching an instance from the on-demand pool that's available. So if there is on-demand capacity that's available that customers are not using, and it's a spare capacity which AWS has to maintain to make sure it's making all this capacity available on demand to customers, there is the spare capacity which is available for use. When this spare capacity is available, it's made available at a 50 to 90% discount to customers of the on-demand price. So you are able to leverage this instant capacity pool that's available and use it for your big data workloads, enabling you to scale much higher, which will basically let you boost your results, turbo boost your results much faster. So you might wonder, now that I have said it's a spare EC2 capacity, really how big is this part capacity? Am I able to run any workloads meaningfully using this capacity? So just to keep that in perspective, when you look at an average, every week AWS customers are using more compute capacity on EC2 Spot than customers in 2013 were running across all of EC2. So when you take a look at that, that basically tells you that yes, you are able to run your big data workloads on EMR with EC2 Spot in a meaningful manner. To highlight this example, Clemson University, they have scaled over 1.1 million concurrent vCPUs over a single weekend in a single region using EC2 Spot for their workloads. The testimonial is available on the web page, which is provided at the end of the deck. So you might be wondering, okay, you are giving me instances for 50 to 90% discount off on-demand capacity, and you are telling me I have enough compute capacity to run my workloads in a meaningful manner, then what should I be worried about? Some customers, when they think about EC2 Spot, the Spot instance could be reclaimed if on-demand requires the capacity back. So this does happen from time to time. And when we look at the numbers to come to a conclusion in a meaningful way, you can see that the interruption rate basically is less than 5%. So if you look at the last 3 months of numbers, 95% of spot instance interruptions were from basically customers manually stopping the instance either because their application has completed or the work that they are performing is done, they want to redo it in some other manner. Essentially what we are trying to highlight here is the fact that when you are using EC2 Spot, less than 5% of interruptions are the ones that are initiated because on-demand needs the capacity. So with that said, you could also use this aspect to design fault-tolerant applications that will give you the additional flexibility and leverage to make sure that you are able to get the cost benefits of running your workloads on EC2 Spot as well. So when you are talking about Spot, some of the things that you need to be familiar with is when you are looking at a given region, which is either US West or US East 1, you must be familiar that each region has multiple availability zones. On top of that, you also have these different instance types that you choose for your workload, whether it is C3 here is the compute optimized workload, and there are different instance types for various types of workloads as well, which we'll cover later in the deck as well. So in addition with the instance type, there are these sizes which would allow you to choose how many vCPUs and memory would you require for running your workload. So each of these factors, which include the instance family, instance size, availability zone, region, all of these weigh in into the pricing of the instance, which is essentially a different spot market. So when you're trying to run your big data workloads, if you are able to have that flexibility of running on different instance sizes or in different availability zones or in different regions, that definitely is going to tie in directly into your cost savings as well. So when you are looking at the overall picture, you do want to keep in mind that every single combination is going to be a separate spot market. So you do want to choose what is the best choice for you for your workload given your time and cost constraints. So when you're looking at the spot instances, you might ask, is there a easier way for me to tell if I'm choosing an instance in a particular availability zone with a single instance type and availability zone, what am I looking at the interruption rates? So if you look at the spot instance advisor page, a screenshot of it is shown in the screen here. You could choose per region what OS you want to run your EMR cluster in, and when you are looking at the vCPUs and memory combinations, you can leave them empty as well. The instance type supported by EMR are put in the screenshot here. You can see the last column shows you how much percentage of interruption can you expect if you're choosing a given instance type. So if you scroll down the page, you can see the interruption frequencies increase. So that basically says that a demand for a particular instance type is more. So on demand requires that capacity. So the interruption on the spot instance type would be more. So from this screen, you could meaningfully choose which instance types to pick from so that your interruption rates are low. This is why the flexibility with a given instance type becomes more and more critical for running your workloads, and it's actually a best practice if you think about it. So moving on, so when you come to the EMR workloads, what are all the instance choices that you have? So if you are running a big data workload on a general purpose job, a batch job, which is performing a bunch of general purpose compute operations, so that start with a M4 or a M3. Previous generation ones have much higher chance of availability, so you could definitely take a look at those as well. And when you are looking at learning workloads, which don't really need a GPU processor, then in that case, the C type of instances are definitely a good choice to start with. If you are processing a workload which needs to perform a lot of memory-based computations, then in that case, any X series of instances or R instance types are definitely good choices. We see many customers performing interactive analysis type of workloads use these instance types as well. So if you have a cluster where you have a large data set or a large HDFS file system that you are trying to use in your cluster, then definitely D or a I instance type is a good fit. So with all these, how do we tie these together to the EMR concepts? So in EMR, you must be aware that there are three types of nodes that you could use. Although HDFS has a replication factor that you could set, which can tolerate a loss of one or few nodes a little bit, which we'll choose to explain later in the next slides. But in this particular case of long-running cluster, definitely the core nodes are on demand as well. With task nodes, you have a choice to either go with on-demand or with Spot. All the task nodes are performing is compute operations on the data. So definitely the Spot would be a good fit here, especially given that if a Spot instance gets interrupted, the core nodes are going to redistribute that unit of work to other nodes that are available. So for any long-running clusters with EMR, Spot is definitely a good fit for the task nodes. So with that said, some of the examples that are out there on the case studies. For example, if you look at any type of workload where data is analyzed for surveillance queries or for any suspicious activity, or if you are looking at any JAMP, which basically is a customer that specializes in improving revenue of the advertisers from their mobile app marketing platform. They perform a lot of log analysis using the long-running EMR clusters as well. So if you are looking at any of these workloads, they essentially can show you that for any workloads like log analysis, interactive queries, just by using Spot instances, the amount of spend that you have on your cluster is definitely going to be reduced a lot. So if you are looking at just to recap before we move away from this slide, the master node will keep running, so you choose on demand. The core nodes you could add or remove gracefully. They could be on demand if you have a good amount of data, and depending on your HDFS replication factor, how well are you able to tolerate the loss of a node. But task nodes definitely could be supplemented with Spot because they could tolerate the loss, and core nodes would just redistribute the work again if a node was lost. Now moving on to the EMR nodes with the workload pattern, which is essentially cost driven. So if you are a cost conscious workload that absolutely has to control the budget in a very tight manner, then EC2 Spot definitely could be used across your cluster, across your master, core, and task nodes. What this means is you are designing or architecting your workload in a manner that even though your cluster is terminated, if you lose a master node which is running on Spot, you are able to pick up the job again and spin up a new cluster and run the master, core, and task nodes all on Spot again. So there are customers which these are the transient clusters which run on EC2 Spot all across. So it would be a good fit if your workload is cost conscious and you have architected your workload in a way that basically lets you restart your cluster and redo the processing. So if you are able to choose your instance types in a way based on that instance advisor, which can run for a certain amount of time and then finish running, then definitely you can run the entire cluster on EC2 Spot as well. So moving on to the next type of workload pattern for EMR, essentially what you are looking at is a data-driven workload. In this case, we do, for any data-driven workload, if you think about it, the Hadoop file system, the HDFS file system, is going to reside on your core nodes. What that means is you cannot tolerate or you do not want to really lose your core nodes and redo your processing. In that particular case, definitely you do want to choose core nodes as on demand. In addition, you also don't want to lose master node and risk losing the entire cluster. In that case, so your master node also is on demand. So essentially what we are saying is it's okay to use Spot in this particular case with task nodes and still supplement your compute power at a cheaper cost and get the scale as well, but still be able to make sure your data-driven workload with the terabytes or petabytes amount of data is able to complete its processing basically. So the amount of core nodes that you would add in this particular case to make sure your HDFS file system is scaling enough is really dependent on how much of this HDFS data are you going to store, how much data has to be available locally, and so on. So when you are looking at another workload pattern, for example, application testing, in that particular case, you do want to definitely look at using Spot instances all over the place. Meaning, if you are testing integration tests, functional tests, any of the testing that you are performing for your application, definitely using Spot is a good choice because even if your cluster terminates and goes away, you could rerun that test and just be fine. It's an internal workload, so it's a very good choice to use with application testing as well. So now we have seen all the workload patterns. We saw what type of instance choices and combinations should we use for long-running clusters, cost-driven workloads, data-driven workloads, and application testing, and how these node types could be used and how they could be combined for the best outcome from a scale perspective, time to completion of your job perspective. In this next section, what we are going to do is perform a deeper dive into the choices that are available with EC2 Spot, which could actually help you or supplement your workload architecture or design criteria. So when you're talking about the EC2 Spot choices, we have three main ways you could request your Spot instances with EMR. The first thing is called instance groups. The second one is instance fleet, like you can tell it's a fleet of instances. And the third one is Spot blocks. We are going to see what each of these entails and when to choose a given type, what makes most sense. So when you're looking at your instance groups, the first choice. When do I choose instance group for my EMR clusters? Regardless of whether they're long-running, cost-driven, data-driven, or application testing, when do I choose instance groups? Whenever I am choosing Spot. So if you have a workload where you need a same instance type and you want to make sure your purchasing option is the same across each node type, and you have fine-tuned your application and job specifically for a given instance type, then go with instance groups option. One additional advantage of choosing the instance group option is the fact that you could use auto scaling to add or remove instances for the core and the task nodes. So definitely, it's one of the most popular option that is used. You could definitely fine tune the application very well for a given instance type, and you are able to leverage Spot as well. So if you if you look at the Zillow's blog post on how they run hundreds of batch jobs, they basically have the blog talks very well about it. It has a master node which cannot be auto-scaled, but they have core nodes which they have combined and fine-tuned yarn configuration in a way that works very well with EC2 Spot and leverages properly the instance types as well. So for the developers in the audience which basically want to say, okay, I have understood the concept, just tell me now how am I going to get into business right now if I want to launch a cluster. In that particular case, so if you look at this screenshot here, what we are trying to say is from the CLI, you have your EMR create cluster command with the cluster name. You specify in the release label what version of the Hadoop EMR you want to run, and you are going to define a default role for your cluster to run with, and you are if you want to log into your instances once the cluster is launched, you are defining what key to use, and then here is where the Spot action starts, right? So you have your instance groups where you define your instance group as a master, which is of M3 extra large, and master is always instance count 1. You specify a bid price, which is the maximum price that you are willing to pay for that instance. And then essentially you are going to look at the instance group type, which is the core nodes, and there you are defining, I want my core nodes of type M3 extra large, and I want 2 core nodes at a bid price of $0.03, and your instance group of task node type essentially is going to be again an M3 extra large, but this time it has 4 instances, and you specify a bid price as well. So when you issue this command, you're going to get a cluster ID back. So EMR the managed service is going to go ahead and provision your cluster based on these specifications, and is going to create Spot instances, 4 Spot instances for your task node, 2 for your core nodes, and essentially a master as well. So this is the easiest way you could specify your EMR cluster. Of course, this is just a sample through the CLI. This is available via CloudFormation as well, which we will see. So moving on to the second choice, which is available, which is instance fleets. You might ask, okay, I understand when to choose instance groups. How do I choose instance fleets? So if you want a wide variety of provisioning options, you have the flexibility to choose a mix of instance types, and you do want a combination of on-demand and Spot, then definitely instance fleets is a good choice for you. You could specify a target capacity, saying that I need 10 nodes available or 10 vCPUs available, which are a mix of both on-demand and Spot. unlike instance groups, you cannot auto scale instance fleets. So with that said, when you have any job where you are only saying that run this job to completion, doesn't as fast as I can, it doesn't matter what instance types I choose, then definitely this is a very good fit for your workload. Then let's see how to request the CLI. So like instance groups, it's very simple with instance fleets as well to create a EMR cluster. So when you're creating a cluster, you're specifying your release label, then you have your service role defined, your instance profile, your subnets that you want to run your cluster in, and then comes the Spot instance fleet option, where you are defining what is the target on-demand capacity that you want, and what's the instance configuration that you want to use for that instance, and what's the instance fleet for core, and in case of core, what's the target capacity. In this particular case, the Spot capacity target is 6 and on-demand capacity target is 2, and you specify your instance configurations, which include instance type, bit price, and how much of the weight they're contributing to the overall request here. And that's it. You basically submit this request to EMR, and it's going to provision a cluster for you with this specification that you have given. So moving on to the third choice, essentially we covered instance groups, instance fleets. Then the third choice is Spot block. So when is it a good time to choose Spot block? Essentially, you say, I really am excited about the cost savings compared to on demand, but I do want to make sure that once my job starts, I have to finish it within 1 hour, 2 hours, or up to 6 hours. So the Spot blocks are a great fit in that particular case. You can definitely specify duration anywhere between 1 to 6 hours, and the price is dependent on the duration that you specify. You're only billed for the price either at each hour or the partial hour that the instance is running, and the partial instance hours are basically billed to the nearest second, just like EC2 pricing. Here, what you are doing is, for a little bit more premium, you are saying, I do not want to be interrupted for X number of hours. And it is still offered at a discount compared to on-demand pricing, but definitely you are leveraging both the cost and the time aspects to finish a job and making sure it's finishing in the cluster. So now that we have covered all the three choices for EMR Spot EC2 Spot instances, instance groups, instance fleets, Spot blocks, let's just cover what are some of the operational things to keep in mind. So when you are looking at using EC2 Spot, you definitely want to make sure that you are optimizing the time your instance is running. So if you have any setup that has to be done, leverage the bootstrap to install any software, and make sure that when you are defining how to terminate an instance or handle an instance interruption, choose terminate only. If you choose stop, your yarn scheduler might mark it unhealthy and you might end up losing the data. It's used only typically for troubleshooting, that approach. So if it is a Spot instance that you're using for task node, you just choose terminate and you could probably spin up a different cluster, or if you're using instance groups, you can scale up or scale down if you're done. And in case of instance fleets, you could always supplement it and it's going to retry and get your capacity to a target capacity that you specified when defining your instance fleets specification. So definitely use a combination of these in the way that's best works for you for your workload. Not all workloads are defined the same, so definitely based on the workload, make the correct choice. The idea was to give an overview of workload, some of the patterns we see, and how to choose some of the spot instance types available for those workloads. So to recap, some of the best practices, given all the material that we covered so far, you do want to be instance flexible to get the most benefit with respect to the pricing and finding your instances. Use the spot instance advisor, the interruption metrics, and find the instance that works best for you. You definitely want to size your cluster in a way to complete your job at scale faster. If you're using Spark framework, definitely enable the dynamic allocation of executors so it can handle the Spot instances coming in or going away. Bigger instances with less overall number of instances might run a job to completion faster, so something to consider as well. Some of the customer references that are using Spot in a meaningful way to perform log analysis, analytics, some genomic workloads, batch jobs, recommendation engines and so on are listed here. There might be a workload which is on this page which might ring very well with you, and you might be like, oh, my workload is similar to this pattern. So definitely we can learn from the field and what's out there on how others have done the workload processing with Spot as well. So with that said, just a few points. If you're not running your big data workload on EMR, if you are running a machine learning workload, which is definitely not a GPU intensive workload, you want to consider EC2 Spot. If any container workloads are available, which are launching this ML containers, then definitely you could consider Spot for those as well. You definitely want to look at Spot essentially from a cost and a scale perspective for any of these. Containers are a very good match for Spot just because by design you make the application fault tolerant, and the scheduler aspect of any of the container platforms, whether it is EKS Kubernetes or Amazon ECS scheduler, they all know how to handle the interruptions and retry placing the container elsewhere in the cluster of instances that they manage. So in addition, for anybody that's operating their own Hadoop clusters with any of the third-party software out there. If you are interested, just looking at automation part of it, definitely Spot Fleet has a tagging aspect which might help you. There are these aspects of EBS volumes, encryption, integration with load balancer, and Spot for T2 instances and T2 Unlimited, which might be a very great fit for dev or test workloads. And Spot for Gov Cloud is going to be available soon as well. If you're using Run Instances API for your EC2 instance provisioning, Spot is an additional option. It's just an additional flag switch that you provide to the Run Instances API. So it's a very good fit as well there for any of the workloads that are being run outside of EMR. So I know that I covered a lot of concepts here. So I wanted to show a quick demo using the console here to show you how to use Spot. I'm logging into my console here. So when you log into your AWS console, we'll just cover the EMR aspect for the sake of this webinar. And in this particular case, what we are going to do is we'll create a cluster. So when you create a cluster, you get to choose what are all the software that you provide with your cluster and how your instance and master nodes are there. You might ask, where is the spot option? You need to go into the advanced options to look for the spot options. Obviously, you can choose any of these application software that your cluster requires. In addition, you just go ahead and go next, then you'll see a screen for hardware configuration. Here you are able to definitely choose the provisioning types that we discussed, either the instance groups or spot fleets, basically instance fleets for EMR, and that would cover two of the choices. So how are spot blocks defined? So that's where these defined duration comes in. Like I said earlier, you are able to choose anywhere from 1 to 6 hours, and pricing is basically dependent on how long you have run your workload using this set. So if you are looking at the uniform instance groups, all you are doing is defining for each node type a separate instance group, and you can tell based on your workload if it's a long running one, your master and core is on demand, and if you're and the rest could be spot, and you could say I want like 10 instances with spot, and you can specify optionally maximum spot price, or you could let it be empty. And you definitely want to look at some of the choices here with respect to with different workloads. When you are covering a data-driven or a cost-based workload, you might as well choose all spot for a cost-driven workload. So, and then when you are looking at instance fleets, you could definitely specify a combination of provisioning options that would let you define what all instance types you want for your particular cluster, and how much of those instance types cores would contribute to the overall capacity. And if you want it to run for 1 hour or 2 hours, specify that as well. And you do want, so when you are provisioning with Spot, there is a chance that the instance is not available in capacity right away. So Spot in EMR would retry and keep trying until the capacity is available to provision your cluster. In that particular case, you could say that if you tried for 15 minutes and you still haven't got any spot capacity, you can say I want to terminate my cluster, or you can say I want to just switch to on demand and go ahead and finish my workload. So if it's available, you are definitely optimizing your workload. If it's not available, you're still running it to completion. So there are a lot of choices, and it's a very easy way to get the cost gains. So another way of provisioning that I do want to show you is definitely through CloudFormation. So like you can see in this template here, which is a JSON format, you can see that there are all these roles that you define for EMR. This particular template uses the instance group mode of provisioning for your instances. Like you can see, I have a core instance group and a master instance group. I do not have any task nodes. In my core instance group, I have defined my EBS configuration. I specify that I have 4 nodes, and you tell an instance type that you want to. And if you notice, the only difference would basically be these two switches or flags parameters here with JSON, which is essentially telling it to use a spot market, and you're telling a bid price. And it's that easy to realize cost gains. You look at it and specify these flags, and you are able to run your big data workloads on EC2 Spot. So that brings us to the end of our session today. There are a lot of workload patterns that are available with EMR and EC2 Spot, and within Spot, based on your requirements, we have multiple choices of instance groups, instance fleets, Spot blocks, a wide variety that could work well for the workloads that you have at hand. I just wanted to summarize and say that it's very easy. At least give it a try to see how your EMR workload works with Spot. You will be happy with your cost savings. So thank you all for your time today, and we really appreciate it.